Good morning, James. Can you just confirm that you're able to get me clearly so that we can start? Today is the third day of which we are meeting, and we are looking at, we'll be doing physics, and the topic that we are looking at is current electricity. Okay, so we are looking at current electricity in today's revision program. So kindly confirm you're able to get me clearly so that we can start. Others will be able to join me as we go on, I guess. But we need to start. So just kindly confirm that you are able to get me loud and clear. And also invite others to join as well. Invite some more friends to join as well, as we they might benefit from this. Okay, so we can just start. So what has been arranged today, these are the questions that I've extracted from the past papers. And of course, as solving these questions, if we can solve these questions, if you can solve these questions successfully, then you have no problem on this part of electricity, and that is current electricity. Finding effective resistance, voltage, power, and all that. Okay, so here is the first question that we are going to answer. Figure 1 shows a 6.0 volt power supply connected to two resistors which are in parallel. So the keyword here, the resistors are in parallel. Okay, so you need to find, when you are told in parallel, surely what you expect, you're going to find a question that is asking you to find resistance. That is the effective resistance. Effective resistance simply means total resistance. Okay, so the key thing here is that they are connected in parallel, and of course you are able to see them that they are connected in parallel. The first question is calculate the effective resistance of the two resistors. So these two resistors, calculate the resistance or the effective resistance. And of course in this circuit there are only two resistors. So what do you do? So now there are two formulas that you can use to find the resistance or effective resistance. Now this one, only use it when you have two resistors that are in parallel. So if you have two resistors that are in parallel, what you can use is resistor 1 multiply resistor 2, divide resistor 1 plus resistor 2. This one is a dialect that you can use. So I recommend this when you have two resistors in a parallel. It's going to save you time and of course to avoid mistakes. But there is another one that you say, that you use, which is 1 over R total. RT I'll put for total resistance. By the way, let me also put RT here. Okay, so R total, which is total resistance, is equals to 1 over resistor 1 plus 1 over resistor 2 plus 1 over resistor 3. So in this case, you can continue adding the resistors that are there, but of course they are reciprocal. Okay, so now let us apply the first one. Since we said this first one is the one that I recommend, so since two are in parallel, we are going to use the first one. So now you can put any of these resistor 1. You can put this one resistor 1, this one resistor 2, or you can start resistor 1 or resistor 2. You still find the same answer at the end of the day. Okay, so in this case I'll put this one 1 and this one 2. So on top it requires that we multiply them, which is 4 multiplied by 12, then divide down, we add them, which is 4 plus 12. Okay, so if you are to multiply on top there, 4 multiplied by 12, what is the answer if you multiply 4 multiply 12. So 4 multiply 12 is simply 48. Okay? Is it 48 or 42? 4 multiply 12, it is 48. So 48 divide what? What about if you add them? You're going to find 16. Okay, now you are dividing 16 divide, that is 48 divide 16. And it's going to give you 3. You are finding a resistance that is 3 ohms. Now look at how my work is presented. Look at how my work is presented. So as you are solving questions in physics, these that involve solving, you find that most of these questions are 2 marks. Okay, so now how do you gain all the 2 marks? The first thing that you need to do, you need to write the formula. You write the formula, then you replace in the formula, you replace what you are given in the formula with units, of course. Okay, in some cases, then what is the third one, or the third part? You find the final answer. So these are the stages that you follow. First thing, you need to write the formula. So in the case you're asked to find the effective resistance between 2 resistors, the formula that you've used is this one. Then now I've replaced here, and of course there's this stage, but the final answer, very important. Don't just write 3 ohms. Where is it coming from? And of course, develop a tendency of writing units, because some of you are going to find just the answer at the end and you just leave it as 3. 3 what? 3 mangoes, 3 what? You have to put unit to show that this is resistance, and the resistance is measured in what? In ohms. That is how you work out the second, and that is how you work out the first question. You need to calculate neatly. Okay, your work should be well presented in the logical way. Okay, then now what about the other formula? If we were to use the other formula, can we still find the answer? That is the question we ask ourselves. Can we still find the answer if we were to use the other formula? Yes, we can find the answer. How does it work? So 1 over, that is total resistance, is equals to resistor 1 here we said is 4, so 1 over 4 plus, what is resistor 2? There are only 2, so 1 over 12. Now here you'll be forced to find the lowest common denominator, which is 12. 4 into 12 is 3, so 3 plus 12 into 12 is as the 12 into 12 is as 1, so plus 1. 1 over RT is equals to that. So you're going to have 1 over RT is equals to 4 over 12. Now, at this particular point, you don't want 1 over RT. What you want is what you want is RT, and therefore you cross multiply here. So you cross multiply. So 12 is going to multiply 1, and it's just going to be 12. RT is going to multiply 4, so it will be 4 RT equal to what? This T is like a subscript, or is a subscript, is equals to what? 12. So divide 4, you will get RT equal to 12 divided 4 is 3 ohms. Now, you know what? You know why I said this one is quite tricky? Because when you reach at this stage, some of you are gonna leave, or you're going to leave the answer in that form. You don't need 1 over RT, you need RT, so you cross multiply. So the stress of this crossing multiply is something that most of you cannot handle in an exam with exam fever, exam pressure. So this one is the direct one. When you divide everything, you just end there. So that is how you answer the first question. Now, if we come to the second question, the second question is that calculate the current in what? 4 ohms resistor. Calculate the current in 4 ohms resistor. So we want to find the current in 4 ohms resistor. Now, at this point also, you need to know the relationship, or the formula that connects the 3, that connect resistance, current, and voltage, and that is what we call Ohm's law. Okay, Ohm's law states that the current flowing through the conductor is direct proportion to the voltage, okay, provided other conditions such as temperature are kept constant. Okay, so what I'm trying to say is that the relationship between the 3, that is voltage, resistance, okay, voltage, resistance, voltage, and current. By the way, current is I. In case of those who didn't know, current is denoted as I, voltage is denoted as V, resistance is denoted as R. So now, the relationship or the formula that connects these three is the Ohm's law formula that you need to know. Resistance is equals to what? Voltage over current. So in this case, if you're asked to find current, in most cases you're going to use this formula. That is, if you are not given power, you're going to use this formula to find what? To find current. Okay. So now, since you are finding current of 4 ohms, so on 4 ohms, you are given resistance is equals to what? 4 ohms. Now, what do you need for you to find current? For you to find current, as you can see from the formula here, if you are to make current the subject of formula, it's going to be current is equals to voltage over resistance. So which means for you to find current, you need voltage and resistance. But the big question is that which voltage do you pick? Which voltage do you pick? Which voltage do we pick? Okay, that is the big question. So now, in this one, you need to pay particular attention here. The voltage in parallel, it is the same. So voltage that is flowing through these two resistors, it is the same. So long as they are in parallel, it is the same. And which one is it? Since we only have two that are in parallel, so the total voltage in all these two resistors is still 6 volts. 6 volts. That is the way it is in parallel. Current, but you should know that current is shared. Okay, current is shared according to the size of the resistor. Okay, and of course, we are going to see how all that happen. Okay, so what you should know that voltage is the same when the resistors are connected in parallel. Okay, so the voltage that is here, that is the voltage of the circuit or the voltage of the battery is 6. So the voltage at this one is 6 volts, at this one is 6 volts. And therefore the voltage that you are going to use is 6 volts. So please, this one take note only if they are in parallel. Alright, so current therefore is equals to, what is the voltage? 6 volts divide, what is the resistance? Okay, they are saying on 4 ohms. So resistor here is what? 4 ohms. Okay, if we were to divide this, they should give you 1.5. 1.5. Now current is measured in amps or amperes. Okay, so that is the unit for current. So this is the current. Okay, so this is the current at what? At 4 ohms. So 1.5. Okay, so that is the current. If you are asked to find the current at 12, you are still going to use current is equals to voltage divide what? Voltage divide resistance. So what is the voltage? The voltage still remains 6 volts. Divide what is the resistance? That is 12 volts. 12 ohms. If you are to divide this one, you're going to find 0.5 amps. So look at this, please. We are looking at the current through 12 ohms and current through 4 ohms. Look at the difference that is there. So the greater the resistance, the less the current that flows through. And of course, the smaller the current, the smaller the resistance, the greater the current that flows through. And this is very important. This one is going to help you as you calculate, as you compare this. If you happen to find that when there's where there's higher resistance, you find big current compared to where it is small, just know that you've done something wrong. It has to be this way, because resistance is just the opposition to the flow of current. The higher the resistance, the less you respect current to pass through. So that is how it happened. That is something that is going to help you to counter check your answers, and of course ascertain whether your answers are correct. So please take note of that. Okay, so what is the other question that you are calculating here? They are asking us to find the current in the battery. Okay, to find the current in the battery. Now, if you are asked to find the current in the battery, in this case, you are going to use the same formula. Resistance is equals to voltage over current. But you'd ask yourself, what has changed this time? What has changed? So when you are asked to find the current in the battery, you know that the battery, we are talking about the total voltage. Okay, in terms of voltage, we are looking at the total voltage, which is what? 6.0 volts. And now if you are looking at the total voltage, it means that even if we are to find the current in the battery, even the resistance, we are looking at what? Total resistance. Okay, so finding it's more like find the current in the circuit. In the battery, in the circuit, one and the same. So you need to use total of these combined. Okay, so the combined resistance, what did you find? We found 3 ohms. Okay, so now finding the total resistance, or finding the total current, or rather the current in the battery, we are going to use the total voltage, which is 6, divide the current, divide this one. If you are to make the subject, please, it will be like this: voltage over resistance. So divide the total resistance, which is 3 ohms, 12 volts. Now at this particular point, you just divide, and this one's going to give you 2.0 amps, or just 2 amps. Okay, so the current through the circuit is what? 2.0 amps, or 2 amps. So that is how you find it. I guess you followed. All right, let us look at the second one. Now, the first scenario, we only had two resistors that are in parallel. But other questions that you're going to encounter, okay, I'll not put the question that has only those that are in series. I think those are simple. Okay, so parallel tend to be a bit complicated, but anyway, should be able to go around that because I've explained quite a lot. Okay, let us look at this question now. Now, for this question, for you to know, it's a scenario where you are given two combination in terms of connections. Okay, so in one circuit, you have parallel and of course series connection. Okay, so how do you deal with such questions? And of course, in this one, it says figure 2 shows 3 resistors connected to 12 volts battery. So the battery, or the total voltage here, is 12 volts. It's given here. The first question is calculate the effective resistance. Calculate the effective, or that is A, effective resistance. Now, every time you ask calculate the effective resistance, and it's even saying between X and Y. But where the word appears effective resistance, just know that you're calculating the total resistance. Okay? You are calculating total resistance. Now, since it has been indicated that between X and Y, where is X? Here. And where is Y? Right here. So, whatever is in between here, everything, calculate, add them. Okay? So now, how do you deal with such a situation where you have a parallel connection, and also a series connection? Okay? Parallel connection, how you know that it's parallel connection? Some of you, these resistors, they branch off from the what? The circuit, from the wire. They branch off. As you can see, it's going straight here, but they are branching out. But this one is in line. So now this one, you know that it's in series, and these are in what? Parallel. Now, to find effective resistance here, or resistance between X and Y, the first thing I recommend you find the resistors, or the resistors in parallel. So find in parallel first, then you add the one that is in series. Okay, so it will be parallel, the total resistance in parallel, plus the one that is in series. That is how you work out this. Okay, so now let us find the one that is in parallel, and of course the two are in parallel. So what do? Use that formula, R total, or total resistance, R1 multiply R2, divide R1 plus R2. And what is our R1? I said you can start with any. Okay, 1, this is R2. Or you can start with R1, R2. It doesn't really matter. Okay, so you have 12 multiplied by 6 divide 12 plus 6. What are we going to find? So I said in the first thing, you are calculating these questions, are normally 2 marks. The first thing you need to write the formula, and this is the formula. So I've gained some marks just writing this, and now replacing. Okay, then after replacing, what am I going to find? 12 multiplied by 6. What is the answer? 12 multiplied by 6 is 72. So be able to punch on the calculator and confirm the figure. Then down here we have 12 plus 6, which is 18. All right. Then now what is remaining is for us to divide and find the final answer. If we were to divide 18, that is 72, divide 18, you should be able to find 4 ohms, okay, as the final answer. So be able to confirm that. What we've dealt with is just finding one in parallel. Remember, parallel plus series. So to find the effective resistance or total resistance here, what are we going to do? RT is equals to, I shouldn't have indicated RT here because we're just finding the one in parallel. So RT is equals to 4 ohms plus the one that is in series, you add 6 ohms. And therefore this one we are going to find 6 ohms. That is the total resistance between X and Y. That is how you simply work it out. So like I said, you start with those in parallel, so you add those that are in series. At this level, mainly you are given 2 parallel and of course 1 series. But sometimes you might be given 2 series. Let us say there was another resistance here, which is, let's say, this time around is 3 ohms. How are we going to find, let us say the question is find the effective resistance in what? In the circuit. In the circuit, we are looking at the whole thing. So how do you find in this case? So, like I said, you find in parallel, then add in series. So this time around, you are not just going to add 2 ohms, you are also going to add what? 3 ohms. And therefore, our total resistance would have been 9 ohms. So that is how you look at it. So please, that is how you find the answer to this question that we were given. This one was just the addition information. Okay. All right, so let us look at the second question. So the second question is calculate the current flowing in the battery. Calculate the current flowing in the battery. Like I said in the previous, if you are told the current flowing in the battery, and that is the whole circuit, you consider the total voltage and the total resistance and the formula that you use. So this is the second question, which is question B. Okay, and it's very important as you write also to number your questions. So this one was question A, and of course this one that I'm calculating is question B. I'm using this part because I've run out of space this side, but if there was space I would have gone down here. Okay, so now what is the how do you find the effective, the current here in the battery? So the formula is voltage and current. Okay, so now one thing you should understand is that in this one we are going to use the total voltage and the total resistance. This formula, making I the subject, is going to be V over R, something like this. So now what are we going to do now? We want the total current. Do you have the total voltage? Yes, we have, which is 12 volts. Do you have the total resistance? Yes, right here. And is this what? 6 ohms. Okay, if we divide this one, you find that we are going to find 2 amps. Okay, that is the total current in the circuit. Okay, the question or the last question in this one is calculate or find the current through 6 ohm resistor. Find the current through 6 ohm resistor, this resistor here. Now this part is a bit tricky because this is where some of you get it twisted. How do you easily go about this one? How you go about this one, you should know these things. First, you should know that current in series, okay, current in what? In series is equal to what? Total current, okay, total current in the circuit. So the current that is flowing here is equals to what? 4 amp, okay. But when it comes here, when it enters the parallel at the junction here, the current is shared according to the size of the resistor. So what I'm trying to say is that the current that is here, it is not the same that is here. But you only know that the current that is here at 6 is twice the one that is here, or rather the current that is here at 6 ohm is bigger than the one that is what? That is here. This one is small because the resistor is big. That is what we ascertained in the previous one. So now, as calculating the voltage as calculating the current at this point, we need to know its voltage, okay? Because current at this point, you are going to use the formula voltage over what? I mean, we are going to use current is equals to voltage over resistance. We have already, they've told us that 6 ohms, so resistor is given is 6 ohms. But what is our voltage? So that is the question that is something that we do not have. So I said current in series is the same, but current here is what? Is shared. Okay? One thing to note. Then in terms of voltage, voltage in what? Parallel. Current in parallel is shared, voltage is the same. But voltage in series is shared, current is the same. So it's the opposite of each other. Alright, since we know that now voltage here is the same, here voltage is same and here is the same, but the total voltage or the voltage here is not the total voltage, because some of the voltage is consumed by these 2 ohm resistor here. So now what do we do for us to find the voltages here? The easy way to work around this question is first to find the voltage that is here. Then if you find the voltage that is here, you subtract from the total voltage. The voltage that remains is the one that flows here. Okay? So what is the voltage here? The voltage here, still using the formula, resistance is equals to voltage over current. This time around, we are making voltage the subject. So voltage multiply 1, this multiply that. So voltage is equals to current multiply what? Resistance. So what is the current here? The current is 2. What is the resistor? Is 2. So we can safely say that the voltage here is what? 4 volts. So the voltage here is 4 volts. From 12, if we were to subtract 4, what remains is 8. So here the voltage is 8 volt, and also here it's 8 volt. We can now safely go and calculate the current at 6 ohms resistor. Okay, so current there is equals to, what is the voltage? 8 volts. What is the resistor? 6 ohms. Okay, then if we are to divide here, what are we going to find? 8 divide 6 is going to give you 1.33 recurring. So 1.3 amp. So that is the current that I'm finding for here. Now, if we're asked to find, after you found the current here at 6 ohms, if we were to find at 12 ohms, we just subtract from the total current minus what? 1.33 or 1.3. And of course, this one is going to give you 1.7 amp. So that is how you look at it. So please, that small procedure, you really need to follow it. Okay. All right, I hope you are following. I hope you are following. Okay, so there's patients who want to ask a question. So please, you can go ahead and ask your question before we proceed to look at the other part. You can just simply ask your question so that we can move to the other one. I guess it's not confusing. I guess it is not confusing. Okay? All right, we'll proceed as we are waiting for your question. That is patience. We will wait for your questions, but at the moment we can proceed to look at the final questions that you can look at. I guess there's a final question that we can look at here. Okay, so this is question number 3. So all these questions are coming from the past papers. And of course, these are the hardest questions that I've found. If you happen to find another question, please, you can still post it. And of course, at some point, we can go through the question. Okay, for me, these are the questions. I have a lot of questions, but of course, these are the ones. If I can explain this successfully and you understand, then you'll have no problem with other questions. Okay? Okay, so it was a problem with question C. All right, I'll still go back in summarizing. When summarizing everything, that is question C of question 1, I guess, or question C of question 2, I guess. All right, so let us look at this one. So let us focus on this one first. So figure 3 shows an electric circuit in cloth dryer containing two heaters X and Y connected to two 30 volts power supply. When both switches are closed, the current X is what? 3.5 amp. So we have two resistors here, this one and this one. These are in a cloth dryer. So you're saying when circuit are closed, which means when you switch on this, the current that flow through here is 3.5 amp. Now what is the question here? The first question is calculate the power developed in heater X. Calculate the power. So here there's a new entry question of which we are calculating power. Now for you to know power in this situation, you calculate it as power is equals to voltage multiplied by current. So now they want us to find power. Now, if we were to have the data that we have here, okay, so to make your life easy, also you need to correct some data if you can. So voltage is equals to what? 230 volts. Then what about current is equals to what? 3.5. Now, some of you might be asking, why am I using 230? These are in parallel, therefore the voltage here is the same. So here is 230 volts. Also here is what? 230 volts. So we are using the voltage that is given. So therefore calculating power, and by the way, power is measured in watts. So calculating power, we're simply going to multiply the voltage 230, multiply what? Multiply 3.5. And if you multiply this, you should be able to find 805 watts. That is the power. That is how you earn the 2 marks there. And that's how simple it is. Then, the second question, this one you need to understand English. The resistor X, let us go through it slow but sure. The resistor X is double that of Y. So resistor X is double that of Y, which means 2X is equals to what? Y. Okay? So for us to find Y, how do you do? For us to find, so we are saying the resistor for X is double that of Y. So for us to find Y, since you are given X, what are we going to do? We multiply, is it multiplying? The resistor of X is double that of Y. Determine the resistor of X and Y. So if this is double, but if we were to go back here, we are saying the resistor of Y, X is double Y. So if we were to go back, you're going to find that the resistor of Y actually is equals to what? X divide what? Divide 2. That is how you look at it. Okay? Double, this one I've just put this one to represent double. But in the actual sense, it's just the same as if you find the resistor for X, you divide it by 2, that is the resistor of Y. I guess that one is clear. Okay? So that is the interpretation here. Now, how do we find, because here we cannot find Y without going through X, because X so far, what is given is the voltage and of course current. Okay? So on Y, nothing really is given aside from voltage, which you know that is 230. So how do you find now? So let us start by finding resistance for X. So resistance for X is equals to, what are we going to use? We have voltage, divide, we have current. So what is the voltage? The voltage is 230, divide, what is the current? 3.5 is given. Okay, so if you divide this, it is going to give you 65.71 ohms, of which you can just say 65.7 ohms. Okay, that is the resistance for X. Now we want the resistance for Y. We are saying X is double that of Y. Therefore, for us to find Y, that is the resistance for Y, is equals to what? 65.7 divide 2. Okay? And what are we going to have if we divide 2? We are going to have 32.86 ohms, which is just 32.9 ohms. Okay? That is how we find the resistor for what? Resistor for Y. Okay? I hope you followed up to this point. Okay? Kindly confirm it's loud and clear. You're able to understand. That is what is important at this point. Okay, so now that is one of the questions, or we've calculated 2 questions on this one. Okay, now we haven't found the second question. The second question is find effective resistance. So what we've done, we've just established the resistor for this one, which is 65.7, and of course for this one 32.9, okay, ohms. Now what we want is to find the total resistance here. So since there are 2 resistors, we are going to use total resistance is equals to what? R1 multiply R2 divide R1 plus R2. So now we are going to multiply R1, let us put this one R1, let us put this one R2. So we are going to multiply 65.7 multiply 32.9 divide 65.7 plus 32.9. Okay, on top there, what are we going to find? We're going to find 2159.23. So be able to confirm these numbers. Then down we have 98.57. Now here dividing, what are we going to find as the final answer? The final answer is going to be R total is equals to 21.91 ohms. Okay, so which is 21.9 ohms. So this is the total resistance. Okay, so this is what we had for today. So we've come to the end of the lesson. So please, if you've not liked my page, kindly like my page, and also find me on YouTube with the same name, find me on TikTok with the same name, find me on Instagram with the same name, find me on LinkedIn with the same name. So please invite your friends. Even as we continue revision, or this revision, you might benefit in one way or the other. If you are interested in online tuitions, you can still get in touch. It's never too late, especially those who are writing GCE. You can still do something here. So this is just to help you revise, but we do more in the background. Okay, so if you are interested in the online tuitions, you can WhatsApp me or call the number 0976402563. And please continue inviting your friends to this platform. It might be of benefit. So see you in the next one, of which we are going to look at mathematics. But because one thing again that I mentioned yesterday is that we should be able to have some afternoon, that is lunch break revisions for those who do work. So if you happen to find a chance at that particular time, just for 15 minutes, we can do something. And of course, continue bringing some more questions. Some of the questions will be able to handle them, or you should be able, or you'll be able to give the questions that will be handling. Okay, if you have challenging questions, you can make sure just in the comment section you post them, and of course when I see them, we'll be considering them for revision. So keep it up, and keep sacrificing the little time that is remaining. Otherwise, see you in the next one.